Good morning, student. This is Dr. P. Nageswara from VVIT University. Today we will discuss the projection of points. When the object is a point, first of all, let us know how to identify the object, that is the point lying in which quadrant. So, so we know that this is vertical plane. We are having the two reference planes presently. Now we are focusing on the front view and top view of the images of the object only. So vertical plane and horizontal plane, intersection of the both planes will form a line, that is what we call reference line. Now these are the four quadrants. You know that when we are practicing at SSC intermediate level, actually we will treat these the four quadrants, the first quadrant and second and third quadrant and fourth quadrant. In reality, this line is nothing but a vertical plane, and this horizontal line is nothing but horizontal plane in reality. Now we are considering how to identify the first of all the quadrants. Let us see. Now by visual observation, we can say that the first object, because we are assuming that always the observer will be in this side, and whereas the vertical plane and horizontal plane are transparent, so that even the object lies in the second or third or in other quadrants also we can able to see, because the planes are transparent planes. Now we can visual observation, we can say that the point A, that is which is nothing but object. So this is the object we are considering here as a point. In the upcoming classes, the object may be a line, or it may be a plane surface, or it may be a solid block also. And observer will be always will observe the image, observe the object from this side only. Now we can say that the point A is in the uh, first quadrant. So we can visual observation, we can say that it is the first quadrant. But whenever with respect to the reference planes, that is horizontal plane and vertical plane, we can say that the point A is it is above HP. With respect to the horizontal plane, it is above HP, and it is in front of VP. So above HP in front of VP, whenever it is above HP and in front of VP, we call it as it is in the point A is in the first quadrant. Now similarly for the point B, so we can visual observation, we can say it is in the second quadrant, but we can written as the point B is above HP, but it is behind VP. So above HP, but it is behind VP. So whenever the object is above HP and behind VP, so we can call it as the object will be definitely in the second quadrant. So next one, the object C, it is below HP and behind VP. So we can say that whenever the object is below HP and behind VP, we can call it as will be in the third quadrant. Next and last one, the point D is here in the visual observation. We can say it is in the fourth quadrant. So similarly, with respect to HP and VP, we can say that it is below HP and in front of VP. Below HP and in front of VP. So like this, we can able to identify. First of all, before drawing the images of the this object, we must identify the quadrant of the object where it is lying. So like this, we need to identify. Above HP in front of VP, first quadrant. Above HP behind VP, second quadrant. Below HP behind VP, third quadrant. And finally, below HP in front of VP, finally it will be in the fourth quadrant. Okay. Just now we are familiar with how to identify the quadrant of the object. Now let us go how to draw the images in the front view and top view of the respective object. So now for explanation purpose, let us consider a simple problem. Now we need to draw the projections of the point, that is images of the point like both front view and top view. Let us name it as the point A is here it was given clearly 30 mm above HP and 40 mm in front of VP. So by seeing this, first of all, we can able to identify that because it is above HP and in front of VP means definitely it will be in the first quadrant. It will be in the first quadrant. So let us see the picture how the object is in the first quadrant. So now the object name is A. So and it is 30 mm above HP. This is HP distance. So HP distance is 30 mm. For explanation purpose, from VP distance, it will be 40. So now the object A is point A is there. When we observe from the front, this is the direction of the front view. You know that. So the front view image we will get on the vertical plane. So the image, whatever the vertical plane, we got the shadow, what we call the image of this object on the front view. It is what we call front view because we know that as per standard convention, the point A in the front view is represented as A dash, small a dash. So always remember the image names must be small letters first of all. So here the front view name is small a dash. Similarly, whereas when you look from the top, it is what we call top view. So you will get the image on the horizontal plane. So the top image always we are getting on the horizontal plane. So it is called as top here, and the image name in the top view is it is a small a. Whereas in the case of front view, it will be small a dash. Image names must be small letters, but front view is a dash, top view is a. And similarly, now if you observe, when you observe the object in the front view direction, when you looking in this direction, front view, we can able to see the distance of this object with respect to from the horizontal plane. This distance only we can get. That means in the front view, the image name is A dash, but it is from XY line, how much distance means the distance will be from this distance will be nothing but HP distance. So this distance will be HP distance because in the front view we can observe only horizontal plane distance. So that is nothing but in this case the HP distance is 30. So hence the A dash image point image in the front view from the XY line it is a 30 distance. Similarly, when you observe the object from the top, so the image we got on the horizontal plane top image, its name is small a, and the respective distance from XY line this distance because when we are observing the object from the top, we can observe in the top view the distance from the VPC. When you are looking from the top view in this direction, the object A will be lies from VP at a distance of 40. Hence, in the top view, we are getting the VP distance only. Hence, the distance is here in the top view, that is a small a will be 40. So, this is will be VP distance. So, that means simply we can say that now if it is a vertical plane, just drawing separately to avoid the confusion. This is a vertical plane and this is a horizontal plane. So now you got the image in the front view here on the vertical plane. Its name is A dash and its distance from the XY line. Now you know that this line is called as XY line. This distance is what we call HP distance. Indirectly it is here 30. So that means in the front view always you have to mark the HP distance. Next similarly now we got the top image on horizontal plane. Top image on the horizontal plane. Its name is small a and its distance is 40 here in this case. 40 means when you are observing the top view, we can able to see the only distance from the VP. VP distance. So it is the first important thing we have to remember. Now we identified here first of all the quadrant and we drawn the image in the front view that is a small a dash with HP distance and the top view with a small a and with the VP distance that is 40. For explanation purpose, I was taking these distances. Okay. Now we got the images in the front view as well as top view. But if you see in this picture, the front view is lying on vertical plane, whereas the top image is lying on the horizontal plane, but both are at 90 degrees angle. These planes are at 90 degrees angle. But whereas our drawing sheet is a plane sheet, our drawing sheet is a plane sheet, but to draw the solution, that is to draw the front view image as well as top image, now we should not fold our drawing sheet. So that means I want to see the both the images at the same time. That is the reason I am applying a standard rule to make this is as a single plane, because I want to see the both front view image as well as top image at the same time. So what is that rule means? Always rotate irrespective of the quadrant. Rotate the horizontal plane. Rotate the horizontal plane. Rotate horizontal plane in clockwise direction when we are seeing in this direction. When we are seeing in this direction, now I want to make the plane it as a single plane. Why? Because I want to see both images at the same time. That is front view image as well as top image. Hence rotate the horizontal plane in the clockwise direction by 90 degrees. Clockwise direction by 90 degrees when we are seeing from this direction, in this direction. Okay, so we can see in the picture, this is the direction. When we are seeing the horizontal plane clockwise means we have to rotate like this. So rotate it by 90 degrees. So when you rotate like this, see, it goes everything in the downward direction. Now we can see here, now we can see here, after rotation, this is the front view, that is A dash will be here, whereas this is the top view, whereas the small a is here. That means with respect to XY line, above is front view, below is a top view. We can say that if it is XY line is like this, so after rotation, what happens is the image front view is above XY line, whereas the image in the top view is below the XY line. Now, so that we can able to see the both images at the same time. So finally, it will be like this. That is the main important observation what we made after rotation. So this is the final solution. So as after rotation, the front view is above XY line, the top view is below XY line. So the front view name is A dash with a distance of HP, because already I told you when you look in the front view, we get the front view image with HP distance. In this case, HP distance is 30. Hence, we need to show the from XY line. This line must be perpendicular as well as this line must be with HP distance, because we are observing front view and the distance will be HP distance only. So hence it is a 30 distance. And now the top view is of rotation. We got here, you can see in this picture, we got in the down the XY line, that is the top view is below the XY line. Whereas if you observe carefully, after rotation, both front view as well as top view, they must be on the single line. This single line is called as this after rotation, front view as well as top view as well as front view and top view both are on the same line. This line is what we call projector. That means always irrespective of the quadrant, the front view image as well as the top image always lies on a single line. That line what we call projector line. Hence, to mark this top view below the XY line, so take from the same point from the XY line, mark in the downside of the XY line, below the XY line, with the distance is here, because we are drawing the top view. Already I told you when we are observing the top view we need to get only VP distance. Top view we can able to see the VP distance only. Whereas in the front view we can able to see the HP distance only. So that is the reason you mark the top view with the VP distance, that is a 40. So this is a solution what we have to draw. Simply I can say that draw the first of all XY line. So what we observed, once after rotation, we got above XY line is the front view and below XY line is the top view. That is the reason above XY line is front view. That is draw the A dash point. That is front view is named as A dash because the object is A. That is A dash with the distance is 30. Whereas top view is below the XY line. Take the from the same XY line distance. The distance will be top view will be small a and the respective distance will be 40 from the x value. So like this, first of all we have to identify the quadrant. Now to see the both front view image as well as top image at the same time, from this direction you apply this rule for every quadrant, so that draw the front view image and top image with respect to the x value. So we can conclude that when the object is in the first quadrant, we can say that above x value is a front view, below x value is the top view. That's all. Now we will go with other quadrants also, but I am not focusing on the what are the distances in the front view as well as in the top view. Okay. Now just we want to remember the location of the front view and top view with respect to the XY line based on the respective quadrant after applying this standard rule, that is rotate the horizontal plane by clockwise by 90 degrees. So for this case we got front view above the XY line, top view below the XY line for first quadrant. Now see how to identify the same rule for the remaining quadrants also. So now let us consider. Now the point B is 30 mm above HP and 40 mm behind VP. So if you have any doubts, you can draw these cross lines like this. This is a horizontal plane. This is a vertical plane. Now we can say that it is above HP and behind VP. So above HP and behind VP. So we can say that it is in the second quadrant. Now we are taking the object is in the second quadrant. Now how to draw the solution for this case? So as usual, the observer will be always this side only. So when you look, because it is a transparent plane, when the object is in the second quadrant, even the object is in the second quadrant, even the observer will be here. As these are the transparent planes, when you look in the front view, you will get the image of this object on this plane. So this is the front view image. Similarly, when you look from the top, you will get the image on the horizontal plane. That is, this is a top view, whereas this is a front view. Now apply the rule. That is, what is the rule? Always when we are seeing in this direction, I want to see the both front view image as well as top view image at the same time, as our drawing sheet is a plain paper. So hence rotate horizontal plane when we are seeing from this direction by clockwise 90 degrees. So we can say that clockwise means the horizontal plane in this case will be goes upside, it will goes upside. Both front view image and top view you will get on the this side above the x line. That means in the case of second quadrant, we can say that if this is a horizontal line, what we call reference line xy. So after rotation, both front view and top view where we got above x line, the front view image as well as top image, we must draw the xy line above the xy line. So we can see here, because the front view is b dash here, the distance is we have to mark from HP distance. This is the HP distance. That is from xy line only. All the distances are from xy line only, reference line. Similarly, top is also above xy line. The respective distance is from VP. VP distance is 40. Like this, we have to mark. So first of all, we have to identify the quadrant. Next, we must know where the front view image and top image have to locate with respect to xy line. that is based on the quadrant. Now let us go similarly third quadrant. So now we can see now the point C is below HP and behind VP. Now similarly we can able to draw these lines HP, VP as a lines. So below HP and behind VP. So the object C is in the which quadrant? It will be in the third quadrant. Now we can say that the third quadrant. So now you can able to see the picture. Again, the observer will be here itself always. So when you look in the front view, even the object is here, because it's a transparent plane, you will get the image here. Front view image we will get here. The front view image, that is the speed dash. Whereas when you look from the top side, top view, when the object is here, we will get the image here on the horizontal plane, that is the top. Now as usual, rotate the from this side. When we are observing from this side, rotate the horizontal plane, which direction? Clockwise 90 degrees. So hence the top view what we got here will goes out upside. That is this is what we call top view. This is a top view, whereas the front view is below the XY line. So we can see the solution. So we can say that in the third quadrant, if the object is in the third quadrant, so we can say that if it is a XY line, above XY line is a top view, below XY line is a front view image. It is exactly reverse to that of the first quadrant. So top view will be above XY line and front view will be below the XY line. Same because the top is above XY line, the distance will be top view means VP distance, front view means HP distance. In this case, it is 30, VP distance is 40. So now the last quadrant. So again, we can see the point is D. So when you see, draw these cross lines. If you are having any doubt, assume the horizontal plane as horizontal line, assume the vertical plane as vertical line. So now you can see the point. It is 30 mm below HP and 40 mm in front of HP. We can say that 30 mm below HP. So it is a below HP. And in front of VP. So now we can say that it is in the which quadrant? The point it is in the fourth quadrant. Now we identified it is in the fourth quadrant. Now you can see that this 3D picture. Same as well. And you see in the front view direction, this is the image in the front view, D dash with HP distance from the XY line. Then you see from the top, this is the top image, small d, with the distance is from VP, that is 40. So as well, when we are seeing from this side, rotate the horizontal plane clockwise by 90 degrees. So the horizontal plane clockwise means it will be down, it will be like this. So after rotation, what happens means here in this case, both front view and top image will be below the XY line. So that means in the case of fourth quadrant, if this is XY line, after rotation, both front view as well as the top view, we need to draw below the XY line. This is what we have to remember. So both will be below the XY line in the case of fourth quadrant. Now we discussed when the object is in the different quadrants, how to draw first of all, how to identify the quadrant, And next, how to draw the front view image as well as top image based on the XY line, based on the different quadrants. So this is the conclusion. So what is the conclusion means, when the object is in the first quadrant above XY line, we need to draw the front view image. Below XY line, we need to draw the top image. When the object is in the second quadrant, we need to draw both front view as well as top view above the XY line. Whereas in the case of third quadrant, top view will be above XY line, front view will be below XY line. And whereas in the last quadrant, fourth quadrant, both the front view and top view will be below the XY line. And most important thing, we must remember always, remember two things. If the object name is, let us say, the given object is a point, and if the name is a capital A, don't forget to give the names in the images as a small letter. For example, in the front view, if the object is a point and its name must be, if the object name is A and its name must be small a dash. Don't forget the names must be small letters. Front view will be indicated as standardly, it will be notated as standard notation will be a dash, small a dash, and top view will be small a. These are the things you have to remember. And remember, similarly, always in the front view, we have to mark this A dash from the XY line. With what distance means in the front view, always we are observing the object distance, that is what we call HP distance. So HP distance we must mark in the front view. And similarly, when you are observing from the top view, so we need to draw with VP distance. That is another important thing we need to remember. Front view is a HP distance, top view is a VP distance, and the image names must be small letters. Especially front view is a small a dash, top view will be small a. And one more important thing, if this is XY line, let us say assume the first quadrant we are dealing. That is the front view is above XY line. This is a dash. And similarly, this will be small a. This is a top view. In the case of first quadrant, this is a front view. This is a top. Here the important point is the front view image a dash, the top image a must be on the same line. Please remember this line is called as a projector. And that is one more important point. And the another important point is here including XY line, and projector line, they must be as light as possible because we are drawing the image of respective object. Only the image we must dark in the front view as well as top view. That means, for example, in this case, that front view is a point, that is a dash. This a dash is only we need to highlight because this is the shadow of the respective object. Similarly, top view, the shadow is a small a. The top view is a small a. Sorry, it must be highlighted. Images must be drawn with dark pencil, and whereas the projector line and XY line we must draw with the uh, as light as possible. So thank you, student. We will discuss the respective problems on the projection of points in the next class. Thank you.